So tables and sets. The only trick to know about tables and sets is that you've done it before. We're basically going to be looking at the slope, and as long as the slope remains constant, that means it doesn't change, it's going to be linear. And so let's take a look at what that looks like here for this first table. We would have an increase of 1.5, an increase of 1.5, and an increase of 1.5. So that's consistent on the right. If it's also consistent on the left, this is going to be linear. So our slope would be 1.5 over 1. It's the same all the way through the table. So that would mean that this is going to be linear. The easiest way to do this for a set is going to be to just turn the set into a table really quick. So 1, -4, 2, -2, 3, 0, and 4, 2. So our rate of change on the right, we're increasing by 2. On the left, we are increasing by 1, all the way down. So our slope would be 2 over 1. Since that's consistent all the way through the set or the table, that would be linear. Moving on, we'll take a look at this one. Here we are increasing by 3, then we are increasing by 5, then we are increasing by 7. That is not consistent. It's not the same number all the way down. Over here, we are going by 1, by 1, by 1. And so this over here, these are the same. These over here, not the same. And so one way to think about it is, well, what we have here is we would have on the first one a 3 over 1. We need to think about these as a fraction or a ratio. We would have a 5 over 1 and we would have a 7 over 1. 3 over 1, 5 over 1, and 7 over 1 are not equal to each other. So we do not have a consistent slope. So that means that this would be nonlinear. Alrighty, we're going to do the same thing with the set. We're going to make a quick table. 2, 4, 6, 8. For my x values, 1, 4, 16, 64. So we can see on the left, we are increasing by the same rate. We are increasing by 2s. But on the right, we are increasing by 3, then by 12, then by, I don't know what that is, 48. So the ones on the right are obviously not the same. The ones on the left are the same. So our slope for the first one, we would be trying to say that 3 over 2 is equivalent or equal to 12 over 2 is equal to 48 over 2. That is not true. Those are not equal. So we do not have a slope that is going at a consistent rate. That means that that is non-linear. Okay, so again, for the tables and the sets, all that you are doing is testing the slope to see if the slope is the same all the way through. If it is, it's linear. If it's not, it's non-linear. Let's jump to the next. We've got a slope here of 7, increasing by 7, increasing by 19, increasing by, I don't even know what that is, 37. And over here we are increasing by 1, by 1, by 1. Again, this would be, you would be trying to make the statement that 7 over 1 is equal to 19 over 1, and that is equal to 30, no, that's backwards. You would be trying to say that 1/7 is equal to 1/19 is equal to 1/37. Those are not equal. We do not have a consistent slope, so that is nonlinear. Taking our set, -4, 0, 4 and 8, 2, -4, 8, and -16. So let's test it. We're going down by 6 here, then we're going up by 12, then down by 24. That's crazy. So here we're going up by 4, here we're going up by 4, here we're going up by 4. And again, just to make this clear, you would be, if you were trying to say that this was linear, you would be saying that negative 6 over 4 was equal to 12 over 4, and that was equal to 24 over 4. Those are not equal, so this is going to be nonlinear. Okay, down to the next. We have here an increase of 10, 10, and 10. Here we have an increase of 8, and of 8. So all the way through, we have the ratio or the slope 8/10. And so 8/10 is the same all the way through. So yes, that's going to be linear. Last one for this page, x and y. Negative 2, 0, 2, and oops. Come on, you move out of the way. There we go. And 4. So here in the set, we also have 6, 4, 2, and 0. So 6, 4, 2, 0. So let's take a look at what we've got. We have on the right side, we are decreasing by 2, decreasing by 2, decreasing by 2. On the left side, we are increasing by 2, increasing by 2, increasing by 2. So our slope here is consistently negative 2 over 2, which is the same as 1, but it is constant. So that means that this is going to be linear. Okay? Number 5. We have on the right side a constant increase of 4. And on the left side, we have a constant increase of 1. So here our slope would be 4 over 1 all the way through the table. So yes, that's linear. And for our set, we'll make a quick table. 1, 4, 9, 16. 1, 2, 3, 4. And so obviously these are increasing by 1. This is increasing by 3, then by 5, then by 7. Not consistent, so nonlinear. Okay. And then the next one, we have an increase of 6, a decrease of 3, then an increase of 6. And here we have a increase of 2, an increase of 0, and an increase of 1. So those are both like really kind of out there. So it's obvious that those are not, that's not going to be linear because there's nothing consistent through that table at all anywhere. And so the next one, we've got x and y. We got 1, 2, 3, 4 for our x values. For our y values, we have 5, 7, 9, and 11. And so we are going to have an increase of 2 on the right and an increase of 1 on the left. So 2 over 1, so 2 is our slope. It is consistent. So that is going to be linear. Alrighty, on to number 7. Here we have a decrease of 1, again and again. Here we have an increase of 1. So it is consistent on both sides. So that is going to be linear. Our slope would be negative 1. For the set, quick table. Negative 2, negative 1, 0. 1. Negative 6, negative 4. Negative 2, and 0. So we'll check this out. Here we have an increase of 2, an increase of 2, an increase of 2. Here we have an increase of 1, an increase of 1, an increase of 1. So yes, our slope would be consistent throughout that. The slope would be 2 over 1 or 2. So that would be linear. Number 8, we have an increase of 6, a decrease of 5, and an increase of 0. Here we have a decrease of 3, an increase of 6, and a decrease of 5. So you can tell that there's nothing consistent anywhere in this table. So nope, that is not going to be linear. And then our set, we'll punch a quick table here, 2, 1, 0, negative 1. 2, 2, negative 2, negative 2. So on the right side, we can see that we have an increase of 0, a decrease of 4, and an increase of 0. And on our left side, we have a decrease of 1, a decrease of 1, and a decrease of 1. So the left side is consistent, but the right side is not. So the whole thing is going to be nonlinear because we do not have a consistent slope. And I will have to come back for the video. I'm going to have to pause for a minute. I got to go teach a class. So I'll be back with 9, 10, 11, and 12 in just a moment. Just a little bit. So back with 9. If we look at our table, we have a decrease of 4, an increase of 5, and a decrease of 5. On the left, we have a decrease of 2, a decrease of 1, and a decrease of 4. We can obviously see, oops, and I need to put negatives on there, don't I? Negative 2, negative 1, negative 4. And so we can see that there's no consistency. This thing is going to be nonlinear. Moving on to the set, we've got, to make a little table real quick, 6, 3, 8, negative 6. 7, negative 2. 8, and 2. Now the tricky piece about this is I'm actually going to redo this. I'm actually going to redo this one and put them in order from least to greatest x value, or greatest to least x value, something like that. So we're going to have least to greatest 3, so negative 6 with 2, 3 with negative 2, 6 with 7, and 8 with 8. So I get a negative 4, a positive 9, and a positive 1. So here I get a positive 12, positive 9. Positive 3, and positive 2. So you can see again that there is no consistency there at all. So that is not going to be a function. Okay. And the last one, we got the table. So on this table on the left, we have an increase of 4, a decrease of 4, and a decrease of 2. Over here, we have a decrease of 9, a decrease of 2, and an increase of 1. No consistency, not linear. And then for the set, we'll go least to greatest again, or greatest, so that's what we'll do, negative 10, negative 7, negative 4, negative 1. Negative 4, negative 3, negative 2, negative 1. So over here, an increase of 1 all the way down. Over here, an increase of 3 all the way down. So our slope would be 1/3 all the way through the table. That one would end up being linear. Okay. and 11 and 12. So for 11, we can see we have an increase of 0, a decrease of 2, and a decrease of 3. On the right, we have an increase of 4, a decrease of 8, and a change of 0. So no consistency, nonlinear. And for our set, we got 1, 2, 3, 4, and 9, 12, 15, 18. So an increase of 3, increase of 3, increase of 3, increase of 1, increase of 1, increase of 1. So our slope would be 3 over 1. It's the same all the way through the table. So that one would be linear. Lastly, number 12, we've got an increase of 1 all the way down the right side, and an increase of 2 all the way down the left side. Slope would be 1/2. It's the same all the way through the table. That would make it linear. Lastly, for this whole worksheet, 1, 2, 3, 4, making a table from our set, we got 3, 2, 1, 0. So here a decrease of 1, decrease of 1, decrease of 1. Here an increase of 1, increase of 1, and increase of 1. So consistent on both sides. The slope would be -1. It's consistent all the way through the table. That's linear. And that's going to be it for lesson 21.